be recording, so that way, again, I'll be able to put this video on the YouTube account whenever I get to it. So hopefully sometime this weekend I'll put this one, and Wednesday's up there, and we should be pretty much caught up with those meetings being on YouTube. Okay, so with the most recent lecture, we finally started discussing a very important topic in algebra, but not just in algebra, but in mathematics in general, and that concept is domain. On your homework, there was a question in regards to domain. There was only one because unfortunately the textbook at this point doesn't focus too much on domain until the next couple chapters. But for the time being, one on your homework just to get you started. This is a very important topic, so I want to make sure that everybody understands it. Also in this lecture, we got to linear equations. So we were looking at equations. Obviously, that implies there's an equal sign. We have some unknown variable, which generally we refer to as x, but of course it could be anything. And that we were looking at our methods to solve it. So any direct questions from the homework that anybody wants to go over? Yeah, Haley?
Can you do question number 95?
Number 95, sure. So 95 is a little bit of a word problem, and it's one that's once you see it and once you get accustomed to how we handle questions like this, it becomes a little bit easier. But definitely at first glance, it's not the easiest question on here. So let's take a look at it. So for number 95, it says the sum of two numbers is 28, and one number is 3 times the other. And our task is to figure out what those are. Okay, so with that being said, let's get started here. Katrine, I'll definitely get to 36. Erin, that's up to you. We have the quiz today, so if you can finish the quiz in time, great. If not, then we'll talk about it at a certain point. Okay. All right. So for 95, the sum of two numbers is 28. All right, so the way that we start this is we don't know what these numbers are, right? These numbers are very much arbitrary numbers. The only information that we have is what's given to us, and the first piece of information is that their sum, or the addition of the two numbers, is 28. So I'm just going to pick two numbers and call them x and y. You can call them whatever you want, but in this case, I'll call them x and y here. So I have x plus y is equal to 28. So note that the first piece of information gives you two variables, and it gives you an equation here. So x plus y is equal to 28. That's just from the beginning. The next piece of information says one number is 3 times the other. What that means is you can write this in one of two ways, because again, we don't know which number is 3 times the other, but that's okay. When we'll see that if we, at the end of this, if we do all the work backwards, it really won't matter which way you set this up. So I'm just going to say that y is 3 times x. You could interpret this as x is 3 times y, because it doesn't give you enough information here to really delineate between the two. So all you know for certain is that one of these numbers is 3 times the other. So, okay, y is 3 times x. That's how I'm going to go with this. Okay, well, remember what we know about equal signs, right? If this equal sign means is, right? This says y is 3x. And we have a y in here. So for us to try to solve this equation, we should try to plug in our value of y into this. If we do that, note that for our first equation, we're just going to get rid of one of our variables altogether, right? We're going to just have x's on the left side, and on the right-hand side, we're just going to have a constant, 28. So that's going to be our game plan here. We're going to go ahead and substitute in 3x for y. So in doing so, I'm just going to scroll down here. We're going to have x plus, and now instead of y, we're going to have 3x is equal to 28. Okay? Now we just go ahead and consolidate these. We see that we have x plus 3x, which of course gives us 4x. So 4x is equal to 28. And now we just go ahead and solve for x here. So solving for x, what do? Well, we see that we have a multiplication of 4 here. So to undo multiplication, we divide by 4. and we're going to divide by 4 on both sides, because whatever you do to one side of the equation, you do to the other. And so we see that the 4's are going to cancel out here. We're just left with an x all by itself on the left-hand side. And now 28 divided by 4 should give you 7. So fantastic. We've now solved for one of our variables. But how do we solve for y? We know x is 7. What about y? Well, we know some information about y from our beginning, right? Y is 3 times x. So now that we know what x is, we can solve for y. So y equals 3 times 7. So 3 times 7 gives you 21. So now we know x is equal to 7, y is equal to 21. And should this make sense? Yeah, absolutely, right? The sum of the two numbers should be 28. And if we go and double check this, 7 plus 21 equals 28. Yeah, that checks out. And one number is 3 times the other. Is 21 3 times 7? Yeah, that also checks out. So just doing our quick checks here according to the criteria that we were talking about earlier that the question gave us, this works for both of them. And again, our method was just setting up these two equations, substituting in this case, we substituted in for y, and that got rid of one of the variables. Once we solved for x, we can then go ahead and solve for y, given the same information that we started with. Okay? And now the reason that I was saying it doesn't necessarily matter if you start with y is equal to 3x or x is equal to 3y is because your process is going to be exactly the same. I'm just going to write this over here just in green. If we instead started with x is equal to 3y, and this was your interpretation of the question, that's totally fine. What you're going to do is the exact same thing. You're just going to take because this is x, right, where you're saying 3y is x, you're going to take your 3y and plug it directly into x. And now note, you're going to have 3y plus y, which gives you 4y. And then you would do the exact same mathematics, right? You would divide by 4, then that would give you y is equal to 7. And then, of course, that would lead you to x being 21. So note that the only difference between these interpretations is which variable ends up becoming what number. So the way that I did it, y ends up becoming 21 and x is 7. And then if you interpret it this way, in green, then those numbers are just going to be flipped. But it's the same two numbers. Okay? Okay. If you have time, could you go over 13? Yeah, absolutely. Let's do 36 and then, 36? Katrine, I don't see a 36 on the homework. I see a 39 and I see a 31. But yeah, so let's do Katrine's problem first, and then we'll go back to yours, Kirsten, and we'll try 13. Okay. So Katrine, do you know which one in particular? I know your mic isn't working right now, so hopefully I'm giving you some time here to type out. Okay, so while Katrine tells me what question in particular we're doing, why don't we just go to Kirsten's question, which is number 13, and then we can double back to Katrine's. Okay, so for number 13, again, this was the question in regards to domain. Domain's a very important topic. Domain, the way you can interpret domain is when you figure out the domain, you're essentially figuring out all the possible inputs that you can plug in for that variable. And the way that you do that is you find the particular values that you can't do, right? So there's ones in particular that you can't plug in, so that would just leave you with all the ones that you can. So let's look at the question. We have y over y minus 1 is equal to 3 over y plus 2. And yeah, Katrina, I know that you said 36. I'm saying that 36 isn't one of our questions, so I don't know which one you're referring to. But in any event, so looking at this, again, we're just looking to figure out the domain, right? So for domain, we're not trying to solve for the variable. We're just looking to see all the possible inputs that we could plug in without the equation breaking, okay? So what we're going to do here is we're going to take a look at a particular piece of each of these fractions. Does anybody remember what in particular we're looking at? Hayden, yeah.
The denominator?
Yeah, we're looking at the denominators here. So we're going to be taking a look at the y minus 1 and the y plus 2. The reason that we're doing this is because our first rule, and we're going to see a couple other rules for domain as we go along, but the first rule of domain, which was the one introduced to you in the most recent lecture, is that we can't divide by 0. If we divide by 0, then the fraction falls apart, right? The world blows up and that's it, right? If you try plugging in, any number divided by 0 into your calculator, it's going to laugh at you. So we don't do that, right? We can't divide by 0. So our job is we're going to be trying to figure out when the denominators are 0. So, Declan, help me out here. Let's take a look at the left-hand fraction, y over y minus 1. How do I figure out when y minus 1 is 0?
Don't you make it don't you do y minus 1 equals 0?
Yeah, exactly. You set your denominator, your entire denominator, to equal 0. Perfect. So we're going to have y minus 1 is equal to 0. And Declan, go ahead and just solve this for me. What is this?
That's going to be positive 1.
Yeah, y is equal to 1, right? You just add 1 to both sides. You isolate for your variable. Great, y is equal to 1. So what this tells you is at 1, 1 is your problem point. This says that when y is equal to 1, then your fraction blows up, right? And how do we double check this? Well, of course, you could just plug in 1, right, for y, and that would give you 1 minus 1, which gives you 0, right? For right in here. If y is equal to 1, then you would have 1 minus 1, which means that you would have y over 0, and you can't divide by 0. So this here, of course, is your problem point. And so if we're putting this into interval notation, which is how I always want this to be presented, right? Then how do we write this? So we're looking, basically, I want to rewrite this as all the numbers other than 1. So who can help me out with that? Hayden, sure.
You would write this as parenthesis negative infinity, comma 1 parenthesis, because you're not including it, union with parenthesis 1, comma infinity.
Yeah, and then the other infinity, and then we're going to wrap it up with another parentheses. Perfect. So, and where Hayden is getting this from is, again, what we're looking for is we're looking for all the possible inputs that you can plug into y, right? So from our work so far, the only number that we can't plug in is 1. But we can plug in 2, 3, 4, 5, so on and so forth, right? And that's where this section is coming from. And of course, we can also plug in 0, -1, -2. All the negative numbers also work, right? So that's where this side is coming from. You're trying to just write out all of the possible numbers except for your problem point. And just like Hayden noted, please be aware we're using parentheses here around this point because of the fact that we do not want to include that point, right? So we wouldn't use brackets here. So perfect. Great job. So let's go ahead and move on to the next part. So keep in mind, that was the domain of just the first fraction, right? So we need to do the domain of the second piece. Kirsten, I saw the hand go up. I don't know if that was just delayed or if you had a question.
Yeah, I have a question. So with the domain, I was confused originally because I thought that y meant range. So I don't have to associate with this problem x is equal to the domain and y is equal to the range.
Correct. Yeah. So that's yeah. If you've seen domain and range before, generally we've seen, or I'm sure it's been taught as x is going to be your domain, y is going to be your range. I want to kind of break you all out of the habit of thinking that a particular variable means something, because this could have been any letter. I could have made y, z, q, whatever, and it's all going to be the same thing. You'll see that the domain comes out to be the exact same thing. So you're not really equating this to range here. But that's a fantastic point.
Okay, thank you.
Yep. Okay, so given all the work that we just did for the first fraction, we now also have to do similar work for the right-hand fraction. And the reason is because, again, we're dividing by our variable, right? Our variable is in the denominator, so there's a chance that we can get 0 in our denominator. So we need to figure out when that's 0. So Samara, help me out. What am I going to do here? Okay. Yoav, can you help me?
Are you going to multiply out the denominators? Pretty much like find the greatest common factor and then multiply them out?
Nope. So what we're going to do is very similar to what we did for the first fraction, right? The first fraction, we were taking a look at the denominators here. So we took the y minus 1 and we set it equal to 0, right? So that's going to be our exact same process for this other fraction. We're going to take our y plus 2, set it equal to 0. So Yoav, just go ahead and solve this for me. Y plus 2 is equal to 0. What do I get for y?
-2.
Perfect. And we do that by subtracting 2 from both sides, of course. So we get y is equal to -2. Thank you. So what this tells us now is that -2 is the problem point, right? For the right-hand fraction, we can have any number other than -2. So what we're going to do is we're going to write this out very similarly to how we wrote, this interval notation. The only difference is our only problem point for the right fraction was -2. So we're going to say, okay, from -infinity to -2, union with -2 to infinity. Again, parentheses whenever you're using infinity, so the parentheses will always go for our infinity or negative infinity, and we're using parentheses for the -2's here because we're not including that number. Okay, so the last step that we have to do here is we have to consider, okay, we have two different intervals of domain here for these two fractions. But this is all part of one equation. We're trying to figure out the domain for the entire equation because, of course, y is on both sides, right? It's the same variable on both sides here. So what we have to do is we have to figure out a way to consolidate these two intervals. So keep in mind what we're trying to say here. We're trying to figure out a way to write all the possible numbers that are not our problem points. So our only two problem points that we've determined were y is equal to 1 and y is equal to -2. So I want to write all the numbers that are not 1 and -2. Anybody think they can help me out? So I'll get you guys started. The first piece here is, of course, we can, go as far to the left as we want, right? So like -17, -18, -19, all these negative numbers work, right? So we can start just with our -infinity, because as it goes further and further to the left on the number line, all of those numbers still work. So we're starting from -infinity, and it goes to the right up until we hit our first problem point, right? Our first problem point is -2. So we go from -infinity to -2, and we're not including that point because, again, that's our problem point, so parentheses. I'm going to go ahead and union that because there's more points that we want to include. And of course, we're starting from -2. So who can help me out here? We're going from -2 up until Elise?
1.
Yeah, up until 1. 1 is our next problem point, right? So we go from -2 up until 1. Keep in mind that we have some numbers in between those that definitely work, right? -1 is totally fine to plug in. -1 will not make your denominator 0. 0 also will be fine, right? If you plug y is equal to 0 in, well, then you have 0 minus 1 for the left denominator, which is not 0, and you have 0 plus 2 for the right-hand denominator, which is also not 0. So you can absolutely have 0 work here. And then, of course, this goes all the way up until 1. And then at 1, we stop because that was our problem point from the first fraction, right? And now what we have to do is we just have to determine, are there any other numbers that will work? And like we talked about before, we have this piece, right? All the numbers after 1. So 2, 3, 4, so on and so forth. So all of those will work. So we're going to union that with that last piece, which is from 1 to infinity. So this here, which I'm just going to box in red, this is your final answer for domain. Your domain is, for this equation in particular, is from -infinity to -2, union with -2 to 1, union with 1 to infinity. So we actually see that we have 3 separate intervals, and just to give you all a visual representation of what this might look like, if we're talking about our number line, and I plug -2 in over here, I plug 1 over here, right? Note we would have open circles because we've determined that those are our problem points, right? So we do not want to include those. But all the other points are totally okay, right? So when you count the number of intervals between -2 and 1, we see that there's 3 total intervals, right? There's 1, 2, 3. So it should make sense that when you're writing your final domain, there are 3 intervals, right? 1, 2, 3. Oops. Yeah, there it goes. Okay. Does that make sense? Everybody kind of see where I'm getting this from? Again, domain is sometimes a pretty tricky concept. So I want to make sure that we're all on, the right foot here with the first thing, the first rule, which is, you can't be dividing by 0. We're good? Okay, so let's see. I have a couple minutes left before the quiz becomes active. Let's see if we can get through 39 together. And if possible, then great. Okay, so Katrine was asking for 39. Let's see what it is. We have 3 times 4y minus 3 is equal to, what do we have? 4, and then a bracket, y minus, and then parentheses again, 4y minus 3. Okay, so I believe I said this in the lecture, although I could be entirely mistaken here, and I'll say it here just for, just to codify that. Whenever you see an equation and you see brackets here, you can essentially just treat brackets as an extra set of parentheses. Generally, they, in the textbook, they use brackets just to make it more readable, but this is the same thing as just a parentheses here and a parentheses here. Okay, but again, they try to just make it for readability that they use brackets instead, so that's where those brackets are coming from. So, first step for solving a linear equation is you want to clear out fractions. But in this case, we don't have any fractions, so great. Step 1 is done. Second step, we want to go ahead and distribute as much as possible, right? So on the left-hand side, let's go ahead and distribute. We have 3 times 4y, which gives us 12y, right? I'm distributing that piece first. And next, I'm going to distribute the 3 times the -3. So that gives us a -9. So the left-hand side is now distributed. It's all pretty much done until we can figure out the right-hand side. So the right-hand side, now you might be inclined to try to distribute this 4 first, and you can. That's totally okay. Just keep in mind what you're distributing it to, right? You're distributing the 4 to the y, and you're also distributing the 4 to the entire parentheses. So you can do that. However, it might just be easier for you to work within the brackets first, and then distribute the 4 when you're done. So what I mean by that is, notice how we have a y minus, and then parentheses 4y minus 3. So this piece right here. Well, what we can do is we can distribute this negative sign, right? This is essentially just a -1 hanging out in front of the 4y minus 3. So if I distribute that negative sign, that just flips the sign of the 4y minus 3. So we're going to have this 4. I'm going to bring down the bracket. We'll bring down the y. We have a negative 4y, and then we flip the sign of the -3. So that becomes a positive 3. Okay, so now all we have left to do is just distribute the 4 now. So distributing the 4, I'm just going to bring down the 12y minus 9. Distributing the 4 to each piece, we have 4y, and then we have 4 times -4y, which is -16y, and then 4 times positive 3, which is positive 12. Okay, so at this point, now that we've done all of our distributing, what we have to do is we have to get the variable on one side, right? So that means moving some stuff around, adding or subtracting so that your variable is on one side and all the other stuff that isn't your variable is on the other side, right? So we can go ahead and just consolidate. We see that that's 4y minus 16y, so we can make that 12y before we do any sort of movement. So we have 12y plus 12 over here. Sorry, negative 12y minus 9. And now what I'm going to do is I just want to get my y's on the same side. So I'm going to add 12y to both sides here. So adding 12y to both sides, that's going to clear it on the right. And it's going to make this 24y on the left-hand side, right? So we add 12y to both sides. Now my y's are only on the left-hand side. And in the same step, I'm also going to add 9 to both sides because I want y to be isolated, right? The entire goal is to isolate your variable. So I'm going to move this -9 over by adding 9 to both sides. So this is 12 plus 9 on the right-hand side, which gives us 21. And now the last step that we have, again, we see that we have no other constants to deal with on the left-hand side, right? Y is almost isolated. We just have this factor of 24. So to undo that, we divide both sides by 24, and we get y is equal to 21 over 24. And if you stopped here, I'd probably take off half a point because, again, I want you all to try to reduce fractions whenever possible. Hopefully, you can see that 3 is a multiple of both 21 and 24. So you can pull out a factor of 3 from both. So this would be 3 times 7 up top. This would be 3 times 8. And we see that we can actually reduce 21 over 24 to just 7 over 8. And that would be your final answer. Okay, any questions on this? I know I went through that kind of fast, but for the purpose of time, I just wanted to make sure I could fit that in before the quiz. So are we all okay with this? Okay, so I'm going to go ahead and assume that without any questions on this, you understand this. So with that being said, I'm going to go ahead and clear my screen. The quiz is up, so you can go ahead and get started on the quiz whenever you're ready. Of course, that just means, if you have any questions, please feel free to let me know. I'm going to go ahead and stop the recording here. And when you're done, then just send it to me on OneDrive and you can enjoy your weekend.